All right, welcome to the first of its kind, world-changing manufacturers network. Lisa Ryan has her ears to the ground and her heart in the game. Get ongoing education and new connections right here with Lisa and the Manufacturers Network. Buckle your seat, listen, and spread the word. Here's Lisa.
Hey, it's Lisa Ryan. Welcome to the Manufacturers Network podcast. I'm here today with Berk Birand. Berk is the CEO of Fero Labs, and he co-founded the company to enhance efficiency and sustainability in manufacturing through Explainable AI. With a PhD in electrical engineering and computer science from Columbia University, Berk brings a wealth of knowledge in digital transformation and IoT technologies to the manufacturing industry. So, Berk, welcome to the show.
Thank you, Lisa, for having me.
So share with us a little bit about your background and what led you to doing what you're doing with Fero.
Absolutely. I'm an engineer by training. I have a background in electrical engineering and computer science. My most recent academic stint was doing a PhD at Columbia University here in New York, where I did research in developing algorithms for the telecommunications sector. I worked on developing algorithms that improve the efficiency of cellular base stations. I also worked on developing algorithms for reducing the energy consumption of the fiber optic networks that form the backbone of the internet. So during my PhD is when I got interested in this field called the Internet of Things, which roughly describes a world where there's sensors around the world that communicate with each other. And we developed algorithms to optimize these networks. And ultimately, that was the segue into what we do currently at Fero, namely, while thinking about the different applications and the impact that I could have along with my co-founders, realized that the impact that we could drive in the industrial sector was absolutely massive. And ultimately, we started applying all of our backgrounds to building Fero and building a software-based tool to help reduce emissions in the industrial sector.
Okay. Sustainability is a big theme for a lot of manufacturing companies right now. How is your mission of creating a profitable and sustainable manufacturing industry being realized today? What's your vision?
Sustainability clearly is extremely important. Many industrial companies have asserted goals, 2030 goals and beyond, about reducing their emissions, and they're working very hard to achieve these goals. And of course, societally, this is one of the biggest challenges that arguably humanity has faced. We believe that AI can play a key role in helping achieve a net zero world, specifically within the industrial sector as well, which is where we focus our efforts. But ultimately, we believe that sustainability doesn't have to come at a cost, that ultimately companies don't have to choose between sustainability and profitability, that using AI and using their data, they can actually make decisions that can drive both profitability up by reducing waste, and they can also reduce their emissions and their carbon footprint at the same time. Many of the use cases of Fero, in fact, aligns these dual goals of increasing profitability and improving sustainability goals at the same time. So one of the examples that I could give in this context is steel is, of course, one of our core sectors of focus. And within steel, our customers use Fero to reduce the raw material waste in their production. Now, this is great for profitability because what this means is that companies are spending less on raw materials, which improves their margin, but it also means that their scope 3 emissions in this case also goes down because all the raw materials that they're saving does not have to be mined, processed, and shipped across the world to get to the plant. So our fundamental goal is to drive both profitability and sustainability at the same time.
Are there other ways that it improves efficiency in some of these industries? Manufacturing can tend to be challenging when you look at its impact on the planet and on sustainability. And that is certainly a big theme in manufacturing.
Yeah, absolutely. So ultimately, most of the applications of our type of AI drives some kind of reduction in waste. So it could be that the example I gave previously revolved around raw materials, but we have other use cases of Fero that revolves around producing the same quality goods while taking less time. So reducing the batch cycle time of, let's say, a specialty chemicals process. In this case, This is great because it allows factories to increase their throughput, to increase the amount of volume of production, which directly impacts their top line, but it also reduces the amount of energy that's spent per pound of product that is being produced. So this is another example. In this case, scope 2 emissions would be the targets on the emission side, and on the profitability side, this affects their top line revenue. And almost all use cases of Fero within our core sectors of focus, which are steel, chemicals, and in general the process industries, have these kinds of dual profitability and sustainability goals.
So, can you explain in layman's terms? Because I know AI is, we're not putting that genie in the back of the bottle, and it's still like this magical elixir of programming. So, how does it work? How does it do what you're having it do when it comes to
Absolutely. So AI is, of course, a word that's thrown around quite a bit these days. There has been an increased focus on AI through generative AI and text-based AI models. But ultimately, in many use cases, we focus on the more technical name for this, which is machine learning. And ultimately, the way that I would describe machine learning is that ultimately they're just methods for extracting complex patterns from large and complicated data sets. That ultimately they're the statistical models, so really advanced mathematical models that are particularly good at ingesting large quantities of data. So if you take the manufacturing example, we have customers that have hundreds, some that have thousands of different sensors in their production line that is being fed into Fero. These are temperature measurements, flows, pressures, quality measurements, and typically this type of data has, if you apply traditional type of mathematical tools, the kinds of tools that are used in Six Sigma or lean manufacturing methods, you have to pick one or two or a few of these sensors and do a simpler analysis with scatter plots, typical traditional statistical tools. With AI, and specifically our type of machine learning, explainable white box machine learning, our software can take all of this data and extract very complicated patterns automatically. For instance, it can find out that for a particular product type, when the scrap that is being molten has a particular characteristic, a specific kind of recipe is the recipe that achieves lowest cost and still maximizes the chance of being within quality specifications. With a traditional type of tool, this is very hard for a human to understand. At a high level, the benefit of machine learning and AI type of systems in the manufacturing sector is to take these kinds of complicated data sets and extract patterns that would be very hard or not impossible for a human to see and observe.
Does it keep learning? Does the process keep getting better and better over time, or does it reach a point where it's reached that maximum?
That's a great question. Typically, in the industrial sector, things are always changing. In fact, there are armies of highly qualified domain experts working at every plant whose full-time job is to make sure that the performance of the plant is always kept at a maximum and doesn't degrade over time. From a data perspective, what we see in terms of the machine learning models is that the models have to continuously retrain themselves with new parameters, with new type of production, maybe new raw material suppliers, or even just regular degradation of the assets in the plant. The models have to get new data and always keep updating themselves to make sure that the plant always operates at its maximum potential capacity. So in the absence of this retraining workflow, what would happen is that a model progressively would degrade, so its predictive accuracy would go down. It would not be able to keep up with the changes in the factory, and ultimately its predictions and recommendations will be wrong, which would mean that the plant would start observing quality issues, or maybe the yield of the plant would go down. And being able to retrain these models and always keep them up to date is one of the core functionalities that we've built into Fero that happens automatically and make sure that our customers are getting the maximum value again from machine learning systems.
What are you finding to be the biggest hurdles in convincing the manufacturing industry to adopt these kind of technologies and practices?
One of our biggest goals is to evangelize the white box explainable type of machine learning in the industrial sector. And the reason for this is that typically manufacturers are not the typical early adopters when it comes to technology. And this is for a good reason. When dealing with potential safety problems, or even before getting to safety problems, when dealing with process that deals with high pressures and high temperatures. It's understandable that manufacturers don't want to jump on every kind of hype technology. One of the early observations that we made at Fero is that most of the types of machine learning techniques that were being investigated within the manufacturing world and even broadly within the technology sector were black box machine learning models. That ultimately, these are systems that are going to extract patterns from data, and they make predictions and sometimes recommendations, but it's very hard for an engineer working with such a system to understand why these predictions were made. And what this means is that engineers typically do not trust these systems. They've been running these plans for many years, and all of a sudden this AI machine learning system comes in and makes a recommendation. It's understandable that they ask, why should I follow the recommendations here? We believe the reason for this mismatch is that most of these types of techniques, these black box machine learning models, were developed for the requirements of the tech sector, where the cost of a mistake is actually not that high. That ultimately, if you use ChatGPT and you put in a prompt, and most of the time it gives a very thorough and solid answer, some of the time it doesn't. This is known as hallucinations, and that's typically not an issue for OpenAI. That usually people that look at it can fix the output and doesn't cause a massive problem for the person using ChatGPT. This is not the case in the industrial sector, where a bad prediction could mean that a steel plant or a chemicals plant has to end up scrapping an entire batch of production, which could be costing hundreds of thousands of dollars in lost revenue and lost productivity. As a result, we've developed all of our models to address this point around creating as much trust and explainability as possible. Our models, when they make predictions, they also describe why they make these predictions. And very importantly, our models also provide a confidence with every prediction that they make. And this is extremely valuable because every model will be wrong sometimes. Our models are correct most of the time, but then when they're not confident in their predictions, they can actually communicate this to the engineers and operators so that those folks can fall back to their regular operating procedures. And as a result, what we are aiming for is to build it's almost like the AI system becomes a colleague of the engineers and operators. They kind of work hand in hand. AI systems provide recommendations, and engineers and operators can follow these recommendations when they have trust in them. And we believe that this teaming up AI and humans together ultimately achieves the highest possible return for factories and for the industrial sector.
That's so interesting. When you start working with a company and getting the engineers involved who may not have that level of trust, what does it look like in that kind of team building of building that and getting the engineers involved so that they also feel that they're part of the process and the output from it?
So we believe ultimately that engineers and process engineers, steel metallurgists, chemical engineers are the right people to drive digitization in the industrial sector. This has been also the case with when Six Sigma and classical statistical tools were becoming more prominent in the industrial sector. The movement was to take these statistical methods and teach them in the form of Six Sigma certifications and the belt system to the engineers so that they could use these techniques successfully to improve their plant's performance. We're very much following a similar kind of direction. We aim to do the same thing with explainable white box machine learning and really empower these engineers working at the sites that have all the context, all the domain expertise to optimize their processes. And the way that this interaction begins is with a pilot. So initially we start an engagement with a prospective factory, we enable the software, and we fully realize that we need to earn our customers' trust in this case. It's very understandable that initially there's a bunch of skepticism, and as they're monitoring the predictions and the recommendations of the software, and as they're working interactively with the software, doing shadow deploys and testing the outputs and comparing the outputs and the explanations with what they already know about the factory, they get to build trust over time. And once that trust has been established, the software can be fully deployed in the factory and really achieve the ROI that many of our customers that have been using Fero for a while have achieved as well.
So it's interesting because one of the things that people are most nervous about when it comes to automation and AI are lost jobs. So, how do you see the integration of AI impacting jobs within manufacturing?
This is definitely a big topic. In fact, in the manufacturing sector specifically, there's a big theme, namely that there's most of the experienced operators and engineers are progressively retiring. So there's a mismatch in the workforce with the available positions and the new engineers coming into the sector. As a result, the interesting dimension here is that AI can help with this. Namely, it can be useful for getting the more newer members of an engineering and operator team to leverage the experience of the more senior members through the AI systems. It can actually help with the onboarding and the training of new engineers. And ultimately, we don't believe that there will be that AI in itself in the industrial sector will cause a loss of jobs. And we see this if we look at the history of the other industrial revolutions, the third industrial revolution, with the mechanization and the robots becoming more prominent in the industrial sector. This has actually not led to fewer employees in the industrial sector. In fact, it has led to more. So not only has the productivity in the industrial sector has gone up, but also more engineers and more operators were hired to work with the robots. And we expect a similar kind of pattern with the fourth industrial revolution and with AI as well, namely that the engineers that will continue to work and will run the factories around the world will be able to tap into AI to do more with thanks to the predictions and the pattern recognition that AI can provide.
Yeah, I love that because I think about we have so many baby boomers retiring, the whole silver tsunami. We're losing all of this expertise. And it sounds from what you just said that AI is a great way for them to leave a legacy of what they've done that helps with future generations to get up to speed a lot faster than the 30, 40 plus years that it took them to develop what they've been doing for that plant.
That's exactly right. There's one way of doing knowledge transfer, right? Is, let's say an engineer is retiring. So one way to do that, to transfer this knowledge would be to write, pages and pages of documentation to pass it on to the next generation. That's extremely laborious. And I don't even know that it works necessarily that well. The way that knowledge transfer happens with our system is that these folks have been running these plants for many years, and the effect of their work is in the data that's being stored in the database on the site. The decisions that they make, the good decisions, the bad decisions, and the outcomes are all stored implicitly in the raw data that is in that factory. So when you use a system like Fero that taps into that data and extract patterns, effectively, you're also extracting the knowledge and the domain expertise of all the senior members of the team that have been running this plant for many years. And when you use these same models to make recommendations to the more junior members of the teams, that actually is a way of doing knowledge transfer that's, we believe, more effective.
So, on a personal level, what motivates you to continuously push the boundaries in sustainable manufacturing?
For me, the impact that I can have and the impact that our team has is the reason we'll keep pushing the boundary, and we'll keep continuously improving our software, doing R&D to improve the predictive accuracy of our models. Ultimately, we're seeing so many success stories and so many engineers that tell us how their day-to-day jobs are easier thanks to the software that we built. And the software itself can, in fact, quantify the impact that it's having within these sites. It can measure the amount of raw materials that was not wasted, or the yield that was increased through AI and machine learning. And ultimately, we can also measure the sustainability impact that these changes are having. So when we look at these numbers, that's, of course, extremely motivating. And there's still so much more to do within the industrial sector, within our sectors of focus, and within other sectors as well. And that's the thing that not just keeps me going, but keeps the entire Fero Labs team going, is this mission towards driving for a sustainable future.
Based on your experience, what are your predictions on the future of manufacturing over the next 5 to 10 years, especially regarding sustainability?
I think we're going through a very exciting time in the industrial sector, and in a massive time of change. Many of the fundamental building blocks that have led to factories becoming optimal over the past 50 years are now changing. Specifically, the main method of improving factories' reliability and making sure that the factory was consistently producing high quality goods was by reducing variability. Let's say if you're buying raw materials from different suppliers, you'd be inclined to buy higher quality, more expensive raw materials, because that would, of course, lead you to make sure that you're producing high quality goods. So the main driver for industrial process optimization over the past 50 years has been this reduction of variability. But now we're entering a phase in the transition and in the evolution of the industrial sector where variability is everywhere and variability is expected to increase. So we mentioned the point around the retiring and aging workforce. One of the big themes in the industrial sector is that of circularity. With circularity, what we mean by circularity is that instead of having a consistent input of raw materials in a factory, one plant's waste could become the input to the next plant. Now, this is great in terms of reducing waste globally in the industrial sector. But what this means is that the downstream plant now has a huge variability in terms of its inputs, and it has to adapt its processing to the incoming raw material, which again, it could be good sometimes, or it could be low quality at other times. Another aspect is, of course, energy availability. We're going through an incredible moment of change in terms of different energy sources, and especially with sustainable energy sources, which means that there's now potential variability in terms of the energy that goes into a factory. And ultimately, these are huge opportunities for the industrial sector as well to reduce their emissions, to increase sustainability, and to really make progress towards a net zero world. And this is why we believe AI will play a key role in transitioning from this world of low variability to high variability, adapting to high variability. And we believe that Fero will play a key role in this transition and be at front and center in terms of the plant of the future, the smart factory of the future.
If somebody is listening to this and they have no idea where to even start, what would be a good baby step for somebody considering looking at going to an explainable AI tool?
My suggestion would be to start from the problem. What is the goal that you want to achieve? If you have quality problems, that's a very valid reason to see if the regular tools that a factory is using could be complemented with explainable ML. And then I would say, after starting with the problem, the second step should be to look at data availability. So to think about what data is available around that problem that can drive a solution to that problem. Typically, one of the effects of using data-driven methods, of course, that if the incoming data into the machine learning system or the AI system is not good enough, then the predictions also cannot be trusted. And of course, machine learning systems, and Fero Labs included, will tell you exactly the accuracy that you should expect from a model, and would highlight this garbage in, garbage out problem. But I would say the second step is to decide to verify that there's solid data that's available for solving that problem. And then, of course, third step, if anybody's interested in exploring the machine learning, explainable machine learning direction, they should feel free to reach out to us, and would love to discuss feasibility study with them as well.
Somebody did want to continue the conversation with you. What's the best way for them to get a hold of you?
They can reach out to us from our website. So if they go to ferolabs.com, there's a button for reaching out to us. So feel free to reach out, and we'll get back in touch, and we'll see if our software and our technology will be appropriate for your type of production.
All right. It has been a pleasure having you on the show today, Berk. Thank you so much for sharing so many interesting insights and technologies with us today.
Thank you so much for having me, Lisa. I really enjoyed the conversation.
I'm Lisa Ryan, and this is the Manufacturers Network Podcast. We'll see you next time. Thanks for listening to the Manufacturers Network Podcast. Do me a favor and share this podcast with your friends and colleagues so we can grow this network and connect more fantastic folks just like you. You can either send your buddies to the website at manufacturers-network.com or share the Manufacturers Network podcast on your LinkedIn, Facebook, Twitter, Instagram, or wherever you and your industry friends hang out. The bigger and faster we grow the network, the stronger and deeper the community we'll all have. Thanks again, and I appreciate you.